Hello there. You're welcome to today's Tech Tuesdays webinar on scaling S3 Parquet scanning performance using EMR. I'm Vrinda, your host for today's session. Today we have Srinivasa Gopal, an Informatica veteran from the Customer Success Technologies team. He's been working on data governance and privacy solution and has developed a niche in cloud data management solutions. Before we start this webinar, let's go through some housekeeping tips. The duration for this webinar is 1 hour. That includes 15 minutes Q&A. You can post your queries in the Q&A box. Dial-in participants are muted. The session is being recorded and will be available in the Informatica Support YouTube channel and the Success portal. You'll also be able to download the slide deck from Success portal. Please feel free to put in your feedbacks and suggestions for the session in the post-webinar survey. The Tech Tuesdays webinars are hosted within the Success portal, which is a micro-learning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. We have launched a data governance learning path in the Success portal that will enable you to implement data-centric approach to compliance based on your role. Here are a few important links that you can go over later that will help you in your product adoption journey with Informatica. Over to you, Srini. Thank you.
Thank you for the introduction. Here is the agenda for today's webinar. We'll go through the use cases of scanning the data lake stored in S3, domain tagging in enterprise data catalog, data quality profiling, mapping and scorecarding and data quality, data source preparation, maintenance on an ongoing basis, configuration, and infrastructure needs. Starting with the use cases, here is a typical data flow with AWS having the integration with various Informatica products. We can see the various integration touch points with metadata and data flow along with data flow. We'll particularly focus on enterprise data catalog and data quality integration with the data lake in this particular webinar, although there are many other integration touch points in this particular architecture. Here is an example of a data lake having a bucket with various file systems partitioned by date. Here we can see the various tables right from table 1 to table 2, table 3, along with various file systems stored in Parquet format and partitioned by date and run IDs. And also we can see that sometimes there is other files, including the files like _success, which kind of helps in knowing like whether it's in a same structure or not. So here, in case of partition detection in EDC while scanning through this kind of data lake file system scanner, we should understand that like it should have the same structure across the files, although it is partitioned by date. So if it has the same structure, it is the partition detection would detect that partition and consolidate into an one table view in EDC, right? So the details are mentioned in the partition detection logic here as a white paper. However, at a high level, ensure that you have following the Hive style partitioning, having the same structure in order for the scanner to work efficiently. For some of the files having the _success or that can be ignored by default, you can use the JVM property of excluding some patterns so that it is considered as exclusion criteria, and then it uses other files for the partition detection logic and find the pattern which can be consolidated into a single table. The other option is to scan or profile a logical layer, wherein you can create a logical layer in Hive having EMR, which can be pointed to the S3 file system. Underlying file system can be in Parquet format, Avro, or CSV format. As we see in the diagram here, the S3, although S3 stores a physical layer having various folders and partitioned by date or any other criteria, a logical table can be created in Hive or Athena to point to the physical layer, and the table partitions is pointed accordingly. We can go through the syntax in further slides on how to associate the table to the folders, corresponding folders in S3 by partitions. And if there are complex data types like struct, array, or maps, you can always break it down to the individual columns using the dot qualifiers to create Hive views. So the file structure needs to be in a Hive style partition so that in this case, like it can understand the pattern and consolidate into a table. The recommended execution in this scanning in case of Hive scanning is to be executed on Spark mode. Best practice is to leverage random percentage sampling. This is really helpful when you have a large volume. The SQL query interface provides a better user experience and there is no staging layer involved. Hence, this way you can have a better scanning experience. Hence, here are the scanning options in EDC for S3, and also we can see how it can be seen in DEQ. The partition detection that we saw in the previous slide is applicable only for EDC, and there is no partition detection by default out of the box available in data engineering quality. Hence, abstraction in this way using Hive on S3 approach provides a better view and also the performance and scalable solution. Here are the supported modes. And if you have complex data types, it can be flattened out using the dot qualifiers and expand into views, and then perform the domain discovery or any data quality profiling that needs to be done, right? So in case of data engineering quality, since there is no partition detection logic at present, you can avoid the logic of going through every partition and create a Hive layer and execute on Spark. This is kind of a scalable solution even in data engineering quality since it executes on Spark engine. You can always use a customized data object. If you don't have a view created, you can create a customized data object and to flatten the structure using dot qualifier in custom SQL. The other option is to use a native S3 resource scanning, which if it's following the Hive style partitioning, then it can be used for detecting the partition and consolidating into a table. So it can be broken down into constituent elements if it's complex data types are involved. Some of the catches are like the schema evolution or compatible schemas scenario is on the roadmap, and partition detection currently works with Parquet files only. And in order to execute on Spark, you definitely need a EMR cluster to be configured and integrated with Informatica, EDC or DEQ products. Athena is another approach wherein you can use it as an abstraction layer similar to Hive on S3. Only a difference is that you can execute only on a native engine using JDBC scanner, and it doesn't run on Spark. Complex data types has to be broken down into constituent elements before scanning so that the profiling and data domain discovery provides you the accurate results. Sampling is not supported for profiling, especially this is important with large volumes. This may impact the performance. Hence, out of all these three options for scanning the data lakes, Hive on S3 is a recommended approach if you have especially large volume and you want to have an abstraction layer in order to scan and see the results from a metadata perspective or a profiling perspective. Moving on to the data source preparation. In order to prepare for the data to scan the Hive layer, which is actually pointed to S3 physical layer, in EDC or DQ or DPM products, there are several approaches as we see in the diagram. So the first approach is basically to set up a AWS Glue crawler, which crawls through the S3 bucket and the file systems and generates the metadata tables in and columns and stores in the Glue catalog, which is actually you can point the Glue catalog from the Hive meta store to get all the table definitions in Hive itself. And if you have the complex data types like struct or array or maps, it can be flattened out using Hive views, and eventually it can be pointed as a database to be scanned via the Informatica product. So that is first approach where the Glue crawler takes care of generating the DDLs in order for Hive to be getting the logical layer and scan to work efficiently. The other approach is to use the Informatica developer tool, where you can import the S3 files and generate the DDLs and execute the DDL on the Hive tables. And of course, you can always flatten it out using the custom SQL in customized data object in developer tool, or you can use the flattened Hive views that can be profiled or scanned in respective products of DEQ or EDC or DPM. The key point to note here is that you need to have this as a persistent EMR cluster for either DEQ or EDC. And if you have the EMR as Kerberos enabled, Glue integration has limitations, and this is actually in the roadmap to be resolved soon. Here is expansion on the Hive tables or S3 to flatten views, some of the considerations as well. Try to create a database on the Hive with the supported naming convention. Avoid giving hyphens as the name of the database, and because the scan will fail if the naming conventions are not followed. And create a flattened views. Try to expand this fields using the dot qualifiers into constituent fields in order to get accurate results from a data domain discovery perspective, as it tries to do a data match and a metadata match in order to determine whether it's matching to the data domain that you are looking for. There are some considerations on the naming conventions further. This is on a high level. The link is added here to the AWS documentation on some of the best practices to be followed on the database and table and column naming conventions. Here are the ways to approach in how to create the DDLs in a little more deeper context here, where you can see using a developer tool, you can import the S3 object, generate the mapping, and have DDL and target. You can verify the syntax on pointed to the corresponding slide and execute that, or you can set up a crawler. This is more automated approach if you want to schedule it and keep on refreshing the DDLs on Hive when there is a change in the source system. Or you can always use the third-party tools that can be used as an automated way to generate the DDLs. Here's a approach again, like having this along with the syntax on how you can generate a table on Hive and point to an S3 path. With an example here, we can see the table name and providing all the column names with the data types. Ensure that you have, if you have partition, provide the partition by clause and stored as Parquet or Avro. This represents a storage format, and point to the location of the S3 bucket that is intended to be queried. So this is how you can verify the syntax in the developer tool and ensure that it is in the right shape before executing the profile or scanning. The AWS Glue crawler, you can refer to the AWS documentation where you can set up the crawler and schedule it accordingly whenever there is a addition or removal of S3 files, and scan through accordingly. And you can always use it via EMR or Athena or any other interface. Moving on to maintenance. So whenever there is a change in source metadata of S3 physical layer, it can be addition of a new bucket or table, or changes in the table structure. There are multiple ways to refresh the Hive layer on EMR. Right? So it can be with the AWS Glue crawler on a scheduled refresh so that it can detect the change and update the Hive layer, so that eventually Informatica EDC or DEQ products can be used to scan. Or you can use EDC's change notification feature on the Glue scanner to trigger the change and take action accordingly. So there is no special backup required for the Hive layer that has been created in EMR. So this is a sample process flow if there is an addition of new table. So it can be customized based on your scenarios if you're implementing this solution. So whenever there is a change on the S3 layer, it can be detected when there is a EDC Glue scanner triggers a change notification, and the change notification can be reviewed with an engineering alert, and corresponding Hive layer can be refreshed with scheduling the scan after the changes have been completed in the Hive layer. There is a similar flow when there is a new column or changes in the existing table structure has been detected, so that you can refresh the changes in the Hive layer and just schedule the scan accordingly. Please note that it has to be changed in the Hive table and the views to be in sync and the query works efficiently. Moving on to the scanner configuration, with EDC, you will have a metadata connection and the connection for profiling or domain discovery. If you have the Hive views created, it's best practice to use the JDBC resource and corresponding JDBC driver to be installed. Else, Hive resource type can be used in order to scan the metadata. By default, AWS treats all the views created in the Hive layer as tables itself. Hence, this is something to be noted. And from the profiling or domain discovery context, the native Hive connection can be used along with the Spark push-down profiling, along with the random percentage if you have a huge volume to get better results with optimal performance. From the data engineering quality perspective, the same connection is applicable like a Hive connection from a profiling standpoint. And eventually it can be used in the scorecard as well. Going on to the infrastructure needs, the EMR cluster, here is a diagrammatical representation of how the integration between Informatica domain, it can be EDC or DEQ, which is under the same platform, integrates with EMR. So there are several references provided on how to integrate with EMR cluster, ensuring like some of the architecture perspectives, like it should be under the same VPC, etc., and corresponding ports to be opened. So please refer to the references for some more details on the infrastructure needs in order for this integration to work. The left-hand side we see is on the Informatica domain components like model repository service with its corresponding database. Data integration service plays a major role in taking care of the execution of mapping or profiling and transforming it to a Spark executor using the transformation manager. And EMR takes care of all the execution with the corresponding computation and nodes and along with the Informatica binaries deployed. So here the Spark is shipped by Informatica, so you don't have to configure Spark separately in the cluster. So it is taken care by Informatica deployment. So from the EMR cluster recommendation perspective, please refer to the PAM, product availability metrics, for supported versions that work with your Informatica domain that has been deployed. And some of the basic services are Hive, Hadoop, and include to be configured in your AWS ecosystem, along with security requirements of IAM roles, etc. If you are planning to use the IAM-based access. And from the configuration perspective, you can enable auto scaling. From cost efficiency perspective, you can scale up or down based on the demand. And from a limitation side, like Kerberos with Glue on EMR, it's not certified, and it's in the roadmap to be resolved soon from AWS. DQ and DDC requires a persistent EMR cluster for profiling. So you can temporarily stop it, but try to not to terminate it. There are some considerations highlighted in this link here. Here are the frequently asked questions wherein there's a question on, for example, how the crawler needs to be configured. So there is a AWS documentation link added here, and how the TDL generation tools works with S3 Parquet, or how to size the EMR cluster. All those links and questions have been added here with security perspective as well. You can refer to these separate links by going through like respective docs pages here, along with the integration of Glue catalog, setting up the Hadoop cluster configuration, which provides a connection to execute on Spark. Scanning the data lake file systems white paper is available as well as on the references. If you still have questions, you can always reach out to Informatica representative, and we can have a separate call. This solution was focused around on data lake on S3 with EMR, particularly on the Parquet and partition detection, etc. Similar approach applies to Azure ADLS and Azure HD Insight as well, although this was focused specifically on the S3 and EMR combination. Let's move on to Q&A. Thank you.
Please post your questions in the Q&A box. We will try and answer them. Amy, would you like to call out any questions that came up in our Q&A box?
Sure, Vrinda. I think there is a question from Daniel that the docs for sizing guideline is not working. So I shared the revised doc link, and and the doc team is going to update the previous link to the corresponding link, and that will be fixed. Thank you for bringing that, Daniel. Thank you. But you can always, although there is the sizing guideline provided for various like sandbox layer or production layer, we have seen like customers using auto scaling, so you can have a minimum one node and then you can always scale up by enabling auto scaling, so it better cost efficiency. Yeah.
Thank you, Srini. We have some more time to end this webinar. If you have any queries, please post them. Also, I wanted to call out that the recording will be available in the Informatica Support YouTube channel and the Success portal. As usual, the webinar recording will also have the slide deck. You can download them. Also, right after this webinar, there is a survey. We would like to know about your feedback about this webinar, and if you have any suggestions for future webinars, please let us know through that survey.
Quick thing on one more question that came out. Actually, on the DDL generation, like you can use the crawler, but the Kerberos with Glue, there is a limitation on AWS side that is getting fixed in 6.4 EMR version. So that's on the roadmap. So you can, if you have Kerberos enabled on the EMR cluster, you can definitely use the Glue crawler once that is resolved. That's on the roadmap. I think I have one more question from Venkata that a small demo would have been good. Thank you for the feedback. I will try to incorporate that in future. Yeah.
I think we have answered most of the questions that came in the Q&A box, Srini. I don't think we have any more questions. Thanks everyone for joining. Thank you, Srini, for spending some time for this great session. Thanks everyone. See you on our next Tech Tuesdays. Bye.